So now after talking about it for a bit, let's get started on actually solving this system. We're going to develop a systematic procedure that we can apply to all sorts of situations. Just before we start it though, I want to say one more thing. I think any math student should be able to take this system and solve it using just basic algebra techniques of isolating variables, substituting. What you do is you try to reduce the number of variables till you finally get down to a value for one of them. It's really not that hard to do that without me even giving you any hints or anything. But some of these situations can get kind of messy and complicated and confusing. So our systematic procedure really is going to be helpful. It's like even if you're really an excellent algebra student, you'd get thrown by some of the situations that we're going to see if you didn't have a systematic procedure. So let's start setting up our procedure. Okay, so now we're solving this system, same example we've been talking about. I'm going to take the augmented matrix, which is the matrix of coefficients along with the constant column on the end. And here we are. We're going to get started on part 3 here, where we're going to start manipulating this matrix in a way so that we can get to a point where we can see the solutions to that system. There are going to be certain rules that govern what we can do. And one of our rules is we obtain an equivalent system if we add a multiple of one row to another row of this augmented matrix, okay? And what I want to do is I want to go through several steps of this process first, and then we're going to compare what this means as far as the equations are concerned. So first we're going to just stick with the abstract process for a few steps. And so what do we want to do? Well, typically what we want when we start this systematically is we want our first column of our augmented matrix to have the form 1 with zeros below. This is what we want. So we're going to manipulate the system so that we can get that first column to look like 1 with zeros below. Well, we got the 1 where we want it, so that's good. But see, I want a 0 in this 2 position. So here's where I'm going to apply this idea that we can add a multiple of one row to another row. I'm going to take row 2, and this is the notation I'm going to use for row 2. And I'm going to replace row 2 with row 2 minus 2 times row 1. Now, why am I saying that? Well, I like having this 1 here because it's easy to multiply that and get it to take on other values, right? So I want this to go away and become 0. So if I multiply row 1 by negative 2 and add it to the row below, negative 2 plus 2 will be 0. So this is my way of noting down what we're going to do. Now let's go ahead and do it. So I have to recopy the matrix in another line. The first row stays the same. 1, 1, 1, 1, 4. In fact, only the second row is going to change. I really only want to work on this 2 here, but I have to operate on the entire row in the same way in order if I want to maintain an equivalent system. So I'm going to take row 2 minus 2 times row 1. I'm going to take 2 minus 2 times 1 is 0. I'm going to take negative 1 minus 2 times 1. So that's a negative 1 and a negative 2 is going to give me negative 3. I'm going to take 0 minus 2 times 1 is going to be minus 2. 5 minus 2 times this 1 is going to leave me with 3. 1 minus 2 times 4 is 1 minus 8 is negative 7. So that's how the second row has changed. The third and fourth rows stay the same. 0, 1, 3, 0, 0, 0, 1, 2, negative 1, 1. And notice I'm happy now that I have this 1 with zeros below. Of course, I lucked out in this problem where I only had to make one change, right, to get that. Now what we're going to do is we're going to kind of work down diagonally. Next, I'm going to look at this second column, but not the first entry. I'm going to go down diagonally and just look at the negative 3 and below. So I'm going to go down to the next row, and what I want is a 1 in that 3 position and zeros below. This is what I want. Okay. And now I can't do it all at once. I'm just going to work on it one step at a time. First thing I'm going to do is I want that negative 3 to become a 1. So it turns out we obtain an equivalent system if we multiply a row by a non-zero constant. And that's exactly equivalent to multiplying both sides of an equation by the same number, which is something I think you're familiar with from algebra. So I'm going to take that row 2 and I'm going to replace it with negative a third row 2, because that will give me a 1 in this second position. So now I got to recopy again. 1, 1, 1, 1, 4, 0. Negative 1/3 times 0 is 0. Negative 1/3 times negative 3 is 1. Negative 1/3 times 2, I'm going to have positive 2/3. Negative 1/3 times 3, I'm going to have negative 1. Negative 1/3 times negative 7, I'm going to have positive 7/3. And then I recopy. Okay, so now I have my 1 in that position. I want a 1 but with zeros below, right? I'm trying to get this 1, 0, 0 situation. And so I look at the third row, and I'm going to use the 1 at the top of what I marked in red to change the rows below. Now here I can just replace row 3 with row 3 minus row 2. I'm just going to add negative row 2 to row 3, because that will give me 1 minus 1 is 0 in this next position. Let's see what the result is. 1, 1, 1, 1, 4, 0, 1, 2/3, negative 1, 7/3. And now I'm changing things. Now row 3 minus row 2, 0 minus 0 is 0. 1 minus 1 is 0. That's what I wanted. But now I have to change the other entries. 3 minus 2/3, okay, is 9/3, minus 2/3 is 7/3. 0 minus a negative 1, so you got to be careful with the minus signs. 0 minus a negative 1 is 0 plus 1 or 1. 0 minus 7/3 is minus 7/3. And the last row is the same. So I'm getting there. I now have 1, 0, 1 there. And the next, I'm going to want to work on row 4. And I'm going to do the same thing. I'm going to take row 4 minus row 2. So I use that 1 position to change this one, and then I do the same operation through the whole row. So I'm recopying. Recopying still. And now what happens to row 4? I'm taking row 0 minus 0, 0. 1 minus 1 is 0. That's what I wanted. 2 minus 2/3. 6/3 minus 2/3 is 4/3. Negative 1 minus a negative 1 is negative 1 plus 1 is 0. 1 minus 7/3 is 3/3 minus 7/3 is negative 4/3. So this is where I'm at right now in the process. Okay. Next step, I'm coming down diagonally. Next, I'm just going to work on this position and the position below. I want a 1 and a 0. That's what I want. So I don't want that 7/3 there. I want to replace row 3. I want to change it in a way where I get a 1. So I'm going to multiply by the reciprocal. I'm going to multiply row 3 by 3/7 row 3. And I'll recopy this on our next page. So I have 1, 1, 1, 1, 4, 0, 1, 2/3, negative 1, 7/3, 0, 0, 7/3, 1, negative 7/3, 0, 0. Now, I just goofed. So I was changing my row 3 here, so I didn't want 7/3. I have to take 3/7 times each entry. I get 0, 0. 3/7 times 7/3 is 1. That's actually a 1. 3/7 times 1 is going to be 3/7. And 3/7 times negative 7/3 is going to be negative 1. It's the 4th row that I was jumping ahead of myself. So in the process here, I was just trying to get a 1 in that position. Now, I want to do this, finish this in another segment, so I'm going to clean up my box here, and we're going to continue in the next video.